So in the last few minutes, maybe I'll move this down. In the last few minutes, we want to talk about the fallout of all of these great experiments and all of these great results. So we now know there's an electron and a nucleus. So they're subatomic particles. What does that mean in terms of what people thought they understood about atomic theory? So we had this question then. OK, so we have a nucleus, positively charged, and an electron, negatively charged, and there's a distance between them. They wanted to know, why do they stay apart? Why does the electron not crash into the nucleus? So from classical description, we have Coulomb's force law, which tells us about the force when you have two charged particles, Q1 and Q2, so the charge on the particles. And you have over 4 times pi times this E0, this permittivity constant, times the distance, r squared. So if you apply a force then, and you have charged particles, if those particles have the same sign, then acceleration should push them apart. The force should be positive and repulsive. So two things with the same charge don't want to be near each other. It's going to be repulsive. If, like in this case, you have two things that have opposite signs, acceleration should pull them together. And here, the force should be negative and attractive. So that's the situation we're in here. Positively charged nucleus, negatively charged electron. So let's consider then a hydrogen atom. Z equals 1 electron, 1 proton. Let's think about what happens when you have an infinite distance between them. So if they're infinitely far apart, what is going to be the force? You can just yell out the answer. 0, right. They don't feel each other. They don't know anything about each other. They're infinitely far apart. There's no force. But that's not going to be the situation in the atom. Atoms are small, so they're going to be somewhat near each other. Now we can think about what happens if they're right on top of each other and r is 0.